So today we're going to talk about rational square roots. I'm going to review a little bit, even though this is something we did last time. So who remembers from last time? We went through this quickly. So before I talk about rational square roots, I'm going to talk about rational numbers first and irrational numbers. So what are rational numbers? Yes?
Any number on the line that could be written as a fraction.
Correct. Any number that could be written as a fraction. Okay. So it's a little review. We did this last time. If you don't want to write this down, that's fine. Let's just review real quickly. And of course, some examples for these. Here I have some examples. Half, -3/5. Right? These are fractions. 1,000. Guys, is 0.7 a fraction?
Yeah.
Is 7 over? No. 7 over 10, right? Okay. What about 0? Guys, I need you to pay attention now. 0, is 0 a fraction? Yeah, 0 over 1. Good. What about 0.3333? It's a fraction, really, right? Because 3 with bar on top. Right, right class? 0.3 with bar on top is a fraction because it's 1/3. So is 6 with bar on top, it's 2/3, right? What about 8.12343434 where it repeats 3/4? Is that a rational number or irrational number? Could we write that as a fraction? Yeah, it's a rational. It turns out if any of these things repeats, if any of these decimals repeat, then you could write it as a fraction. Okay. Does that make sense? So if a number has a decimal places and if it repeats, has a pattern, then it's a number that you could write as a fraction. It's a rational number. Of course, then irrational number, as we learned last time, is what class? Number that you cannot write as a fraction. And do we know of a such number where a number you cannot write as a fraction? Yeah, one person knows? Okay, go ahead.
Square root of 5.
Square root of 5, sure. Shanzu, can you give me another one? A irrational number? Pi, sure. These are number that, yes, another one? Square root of 2. Yeah, so these are number that, so pi and so forth. These are number that you cannot write them as a fraction because when you write them as a decimal, if you punch in the calculator, they go on forever, the decimal places, but they never end, right? And they don't repeat. Because if they did repeat, then it would be rational. Okay. How come I have put a big X mark on square root of 4? Shrub?
Because it's 2 equals 2.
Yeah, square root of 4 is really 2 because 4 is a, what kind of number is 4? Do you guys remember? Yes. Yeah, it's a square root of a number, right? 4 is square root of 2, right? So therefore, 4 is called a. Does anybody know when you have a square of a number like 4? What else? 9, 16, 25, 36. What are these numbers called when you have a square of a number? Yes. Okay. Radicand is what's inside the square root, yes, but there are some special radicands, like 4 perfect squares. That's correct. So, good. So these are called perfect squares if you have something squared, right? If you have a number squared, this is called a perfect square. And we like this perfect square because here's a fact. If I have square root of a perfect square, yeah, it cancels out. You could think of it as like kind of canceling out like this, and you get that radicand. You guys said it. It's called the radicand, right? Does that make sense? Yes. This is kind of a review, right? We talked about this before. So let's move on. By the way, are these then square root of a perfect square? Are these rational numbers? I said these are rational numbers. Why are they rational numbers when you have a square root of a perfect square? Yes, that could be written as a fraction. Isn't that right, guys? So for example, if I have square root of 4, that's 2 over 1, right? Square root of 9 is 2 over 1. Square root of 16 is 4 over 1, and so forth. Does that make sense? So by the way, what does square root mean? What are they asking when you have like square root of 4? What does that mean really? One person? Andrew, what does it mean when I have square root of a number? Yeah, what does square root asking you?
Basically find what number squared is the number you're trying to find.
Exactly. What same numbers can you multiply that equals to the one inside the square root, which is called radicand, right? That's exactly what it means. So look, square root of 4 is asking what? Really, it's asking what two same numbers can you multiply and to get 4? The answer is 2. Square root of 9 means what two same numbers can you multiply and get 9? Is 3, and so forth. You all know this already? Great. Yes, this is, yeah, so there you go. You all know it. All right, and in fact, we also talked about this. All real numbers are made up of set of all the rational numbers plus set of all the irrational numbers. So if you were to pick a random point from a number line, it'll either be what? Rational or irrational. Very good. So it really helps if you watch the video, right? It's kind of nice review. So yeah, before you coming in, you could actually watch the video that's, for the next section. It will really be helpful, I think. Anyway, so let's kind of get into what I really want to talk about here is, so again, square root of a perfect square, you get a, it becomes a rational number. Yes, like it becomes square root of, like 4 becomes 2. I wrote this down. Anybody see why I wrote square root of -4 is undefined? This was in the video. Who remembers what I said? Why is square root of -4 undefined? Well, isn't 4 perfect square? Derek, why did I say it was undefined?
Because you can't have a square of a negative because both numbers would have to be either negative or positive.
Exactly.
They would still equal.
That's right. When I'm asking square root of -4, what I'm asking is what same two numbers can you multiply and make it equal to -4? Is it ever possible to have two same numbers and then when you multiply it becomes negative? No. They'll either be both positive or both negative. When two numbers are both negative, what do you get? What's negative times negative class? Positive. So this is it's not possible. So therefore, square root of -4 is undefined. Okay? No, square root of 4 is not -2, it's 2.
Yeah, square root of a negative.
Ah, that's a good point. Guys, that's a good point. Somebody said, isn't square root of 4 -2 because doesn't -2 times -2 give you 4? But let's think about that for a second. That's a very good point. So then is square root of 4 equal to -2? The answer is
Yes.
no.
Oh no, it's 2.
This is not true. Why do you think
Oh,
square root of 4 does not equal to -2? Yes, sir.
that's because you only include like the -2 when you're solving.
Okay, good. In other words, Maddie, what is this number positive or negative? Can a positive number equal to a negative number? No. Okay, so when you're simplifying, right? Positive number is never a negative number. But what Kobe is saying is this: if you're solving, Maddie, if you're solving something like this, class, are you watching? Because a lot of people get this wrong. If you're solving something like this where you have x squared is equal to 4, here we're simplifying, right? We're saying what is square root of 4 equal to? That is 2. Because positive number is always positive. It doesn't become negative all of a sudden. But here, when I'm asking, well, what does x squared equal to 4 gives you as the answer? The answer is there are two possible answers. X could be -2 or, yeah. So here we're simply simplifying. Here we're solving. So when you're solving, you're looking for every possible solution. Here we're simply solving. What does positive square root 4 become? What's that equal to? Well, it's equal to not -2, because positive number can't be negative. It equals to +2. Question?
What's the plus minus?
Oh yeah, we'll get there in a minute. Okay, good question. Okay, so, but is it okay to have, let me hide this. Is it okay to have negative outside the square root, like this? Yeah, this is fine. This is simply, there's an invisible 1, right? This is simply -1 times what? Square root of 4, which is 2 squared.
Yeah.
So the answer, this comes out to be then -2. So I would like you to now, this is all review, but I would like you to now, everybody, can I have your attention? Is this statement true? Every square root of a number is going to be positive. Square root of a number would always be positive. Is this true? Well, here, I got a negative answer. Yeah, that's because, you're right. Negative is outside. Does that make sense? But if I'm just looking at the square root of some number, it always has to come out to be positive, correct? It's never negative, right? You could have negative and some other numbers outside of it, right? That doesn't really matter. What about 0? What's square root of 0? 0 is 0 squared 0. Okay. So do you guys remember the product property of square roots? What is the product property of square roots? Who remembers? Since you watched the video, you should all know. Caroline, do you remember what a product property of square roots was? Good, you got the idea. Okay, so what does square root of AB equal to? Exactly, and because this is true, we could do a factor tree and see if we have any perfect squares inside. That's exactly right. Do you guys remember this? So, by the way, does it work for sum of numbers inside a square root? No, it does not. Right, guys? Who can give me a counter example? Why doesn't this work? Isn't square root of A plus B equal to square root of A plus square root of B? Why does somebody give me a counter example? Yes, sir.
Isn't it multiplication?
Yeah, only multiplication works, but how come addition doesn't work then? Guys, do you know what I'm asking? Yeah, only this group. I know that you saw the video, but you need to still participate here. Yes. Yeah, show me a counter example, which means an example that shows that this doesn't work. What?
Square root of 3 plus 4, which is 7, is not the same as square root of 3 plus square root.
Good. You could kind of verify that with the calculator. But let's just use perfect squares for example. Hold on. Here we go.
No, we should like do the notes at home, because then when we do the homework, we always have questions, and then you're not there to answer. So we should do the notes at home, and then do the homework here, so you can answer.
Yeah, that's why I asked you to watch, but some of you couldn't watch. So hopefully, yeah, we'll do that. We'll do that next time. Let's see if it works. Okay. Here we go. Okay, so who could give me then, class? Who could give me a counter example? One person? Really?
What for what?
So somebody gave me a counter example, but you have to use a calculator. Could we do one where you don't have to use a calculator?
You do the long way.
How about, yes, Chansu? No? Square root of, like, how about 4 plus, I don't know, 25? Guys. No, not 25. Square root of 4 plus
8,
16. Something like this. Does this gives you square root of what?
6. Oh, 4 times. No, 4.
So what do you get? Is this square root of 4 plus square root of 16? Is it? No, because this is square root of what? 20, which is equal to what? 2 plus 4. If this was true, you get 2 plus 4, which is what? 6. What is that 6 in terms of square root? Square root of? 36. Is square root of 20 equal to square root of 36? No, you see how it does not work. Okay. Does that make sense, guys?
Okay, so instead of like adding them in the first like bracket, you have to separate them.
Yeah, I'm saying this does not work. If you have a yeah, see, and if you did that, it doesn't work. The left side does not equal to the right side, does it? I'm just showing you that this does not work. Right, guys? You cannot separate, if I have square root of a plus b, you cannot separate them into square root of a plus square root of b. Here's an example that shows you why it doesn't. You see what I mean? Okay. All right, so can you then do square root of 900? Could we simplify this using the first fact? Okay, Matt. Matt? Yeah, you could do square root of 9 times square root of 100. Or you could do what? Square root of? Yes. Yeah, question. Here's a question.
Do we like have to do that, or can we just know that it's
If you already know then. But sometimes you don't know. Like for example, yeah, here, if you knew that, then you know it's square root of 30 times square root of 30. But you could have done square root of 9 times square root of 100, right? So you get 3 times 10, or 30, square root of 30 squared is 30. But what if I give you something like this? Square root of 1296. Do you guys know off of hand what that's square root of? So guess what? You have to do a factor tree. So I'm going to give you a chance then. Go ahead and do a factor tree and see what you get. Because by doing a factor tree, you could actually figure out what is square root of. So if you do a factor tree, I know that it's even, so 2 goes in, 648, 2 goes in, 324 times, and so forth. You should have all gotten something like this, okay? How come I didn't stop at 9 times 9? Because when you do a factor tree, these are prime, right? Prime numbers that you have to go all the way up to, right? So 9 is not prime, so you have to go 3, 3. So how many 2's do I have, class? How many 2's? 4. How many 3's do I have? 4. Should I write 2 to the 4th and 3 to the 4th, or should I write? I wrote it this way. How come I didn't write square root of 2 to the 4th and 3 to the 4th? Anybody know why? Guys, you know what I'm asking? How come I did not write this as square root of 2 to the 4th times 3 to the 4th? Why did I separate it? Yeah, why do you think I did?
Like square root can cancel with the...
Yeah, because when you separate all this together with square roots, right guys, we just learned square root of aren't these perfect squares? So I just separate them as perfect squares. So you get, right, square root of 2 squared is just 2, square root of 3 squared is just 3. So how many people got 36? That's the answer. Does this make sense? Yes? Okay, good. All right. So this rule 2 is called quotient property of square roots. Okay. This is where you don't have your video. The video got cut off. Anyway, so if I have the rule 1 was product property of square roots. What do you think quotient property of square roots might be? Yeah.
like in a square root, it's a fraction?
Yeah, square root of a fraction, like square root of a over b or something like that. Okay. So if I have something like this, what do you think? Anybody have any guess? What do you think this is equal to? 1 person? 2, 3, 4? Andrew, what do you think?
I think it's equal to the square root of a over the square root.
That's correct. It's equal to square root of a over square root of b. Okay. So knowing this, you could actually simplify things. Okay. Also, if you have a fraction, do you think you should always try to simplify it as much as you can? Yeah. Inside the square root, the radicand, if it's a fraction, you should always try to simplify. And also, it turns out that later we'll learn this actually on next section. You cannot have square roots on the denominator. That is not simplified. Just like exponents, you cannot have negative exponents. It's not simplified. You cannot leave the denominator as square roots. Okay, it's not simplified then. Yeah, so we'll actually learn how to fix that later. Anyway, so if I have something like this, negative square root of 64 over 169, this one's really easy because you could rewrite now using this fact, this rule, that negative square root of 64 over 169 is same as negative square root of 64 over square root of negative square root of 8 square over negative square root of 13 square. You all saw that 64 and 169, weren't they perfect squares, right? So this simply becomes negative 8 over 13. Easy? Does that make sense? Now this one was easy because these two numbers, the numerator and the denominators were, Anais, they were perfect squares. You saw them easily, right? But what if I give you something like this? By the way, if I have, if I have plus or minus in front of this square root, how many numbers does this represent? Two. What are they? What are the two numbers? Yeah, positive square root of this fraction or negative square root of the fraction. Yeah, so this is a shortcut. Listen, this is a shortcut of writing two numbers that happens to be opposite of each other. Does that make sense? Some people think that this represents only, guess what? Only one number. But can a number be positive and the negative at the same time?
Yeah.
No, you can't. You cannot have a number unless it's zero. Well, zero is neither positive or negative. But other than that, a number cannot be positive or negative at the same time. Does that make sense? So then how are we going to do this? Factor 3 is correct. Do you think we need to do factor 3 for 576 and 1225? Go ahead, everybody do the factor 3. Because no, you cannot look at the back of the book because on the test, right, you don't get to use the table. So everybody go ahead, try. I'll give you time. Okay, so by the way, this means two fractions like this, right? And you could separate the numerator, right, with the square root and the denominator with the square root. When you did the factor 3, I got this. How many people got, it doesn't have to look exactly like this, but these leaves, these are called leaves, right? At the very end, you know, these, what do we call these? These are the, what guys? Well, leaves, but why do we call them leaves? Why do we stop? How come we don't? Yeah, these are the, yeah, they're prime. So you stop at the prime number, these are called leaves because it's the whole thing is a tree. So did you get, how many 2's did you get for 576 as a factor? 6 of them. How many 3's? 2. For 225 you get 2 5's and 2 7's, isn't that right? So it's kind of nice. I wrote it this way again, over, right? I get 2 square root of 2 square, 2 of those, and 3 of those, and then 3 square root of 3 square, one of them. The other one, so did you all get the answer as plus or minus 24 over 35? Yeah. How many people got this? Raise your hand. If you didn't, check your work because you get 3 of these, 2 to the second power, right? Because you have 6 of these, right? And so this becomes 2 times 2 times 2, and then you get 3 square root of 3 squared, you get 3, and you get 5 times 7 on the denominator. How many numbers? How many fractions? Question.
Yeah, what happens if you don't get like pairs? So you don't get
Right. What happens if they don't always? So all the stuff that we've done so far, they're all pairs. Yeah, sometimes they will not be paired like this, right? So this is next time we're gonna learn how to deal with these. So it turns out, so these are always you're gonna always have perfect squares as the numerator or denominator, but they don't have to be always perfect squares, do they? So we'll deal with that next time. Very good question. Now, how many numbers does this represent? This fraction, 24 over 35. This represents 2. Negative 24 over 35, and what? Positive 24 over 35. Don't think that it's one number. Does that make sense, guys? Yeah. I'm sorry? Say it again? Yeah, it represents 2 numbers, doesn't it? This is equal to negative 24 over 35 and also 24 over 35, right? That's what plus or minus positive or negative 24 over 35 is. That's what I'm saying. People think that this is one number. It's not. It represents 2. Correct? Are we good?